Yeah. So yesterday we started discussing about ch mode, ch1, and a few of other commands. So if you want to know that what are all the commands that we have discussed earlier, the only option what we are having is we'll try to use we'll use the history command. So history is a command. So with help of history, we'll come to know that what are all the what are all the commands that we ran previously. So previously, yesterday, as part of yesterday's class, we only discussed about two commands: cho to change the ownership of file, chmode to change the mode of privileges, and sticky bit. What is a sticky bit? And we have already created some examples, and we tried that. Sticky bit is straightforward. So with the help of sticky bit, we can able to protect a file or directory without to delete by others. I mean group and others, even though if they have a permissions, even though they have a permissions. That is the main intent of this sticky bit. And ch1 is used to change the ownership of a file. So if you want to change the ownership of a file, that can be achieved by using ch1. And chgrp is used to change the group of a file. And the mkdir chmod, all these commands are clear now. So today what we do is we also discuss about yesterday what are the other command we have discussed yesterday. So we discussed yesterday even this rm command also we have discussed. Let's open a new session. So here, so even rm command also we have discussed it on yesterday. So here rm. So even what is the intent of rm command? So rm command is used to remove a file or directory from Linux system. If you want to remove a file, we can use -f. If you are hyphen, by default it is interactive mode. If you want to suppress that, we can use -f. And if you want to remove a directory, -r. So -r means recursive ensure. So one of the danger command in Unix is rm-r directory name, or even greater than symbol. As of now, these are the two danger activities. Two danger activities. So why I'm saying that, for example, if I take assume that, so I have a file called test2. I have a directory called test1. So which is having some data. For example, cat. So cat greater than test. Okay, hi, hello. Something I'm typing. So if I execute cat again test. So we do have a hi and hello. Now if I execute history command, history greater than test, not only for cat, not only for greater than symbol, the functionality of greater than symbol is unique across the Linux systems. So greater than symbol, it will try to create a new file. So after whatever the name you are going to specify, so if the file is already available, it override the content. If the file is not available, it freshly create a file. So double greater than means it will try to append it. If the file is not available on double greater than, it will create a file. So always try to use the, if you want to be a safer hands, always use the double greater than. So double greater than also creates a new file if the file is not available. If the file is available, it appends the data. So now, for example, if I mention greater than test, now go ahead and run the cat command. So what it does means it removes the entire table. It removes the entire thing, and nothing is there. So I mean whatever the data. So we added. So all of the earlier we added hi, hello, something, right? It overwritten. That's why. So the functionality of greater than, double greater than are unique across that we can use greater than symbol after successful at the end of the command. If you mention greater than file name, it creates a new file. If the file is available, it overrides the data. Double greater than also same functionality. The only thing is it appends it. It appends it. So today we are going to discuss about commands called CP and MV. CP and MV. So what these commands does. So even in Windows also, even in Windows also, if you want to rename a file, how do we rename a file in Windows? Right click, rename, or F2. okay, or F2. Okay, then okay, after F2, you will just okay add whatever the name you required. So, okay, even if you want to take the backup of a file in Windows, if you want to take the backup of file like in Windows, so let's go to okay here. So documents. So for example, if I want to take the document, if I, for example, now I want to, so take the, I want to rename this file. So in this case, I can press okay F2, okay Fn F2 and rename it. So what is shell? Okay, something I want to add Unix, it will be renamed it. So if you see this one, okay, if you observe this guy, so while okay, for example, whenever I rename a file, so whenever okay, I rename it, so whenever okay, I rename it, so whenever okay, I rename it, minute, so hide, okay. So whenever what happened? Yeah. So whenever in Windows, so for example in Windows, okay, whenever I rename it, the file created date and time. For example, this file is created on 4/29, 2025. So, but okay, here, so with help of okay a rename, with help of rename facility, okay, the date modified date is not changing, and even size is also not changes, and type also not changes, which means that if you try to okay rename a file, for example, assume that if I copy this file and okay, let's move it to some other directory, so even after moving from okay, even I'm trying to copy from one folder to here, I paste it on here. After pasting and here also, the properties of file is not changing, the properties of files are okay, not changing. So in Unix also, if you go with mv command, mv command is used to rename a file, and it also allows us to move it also allows us to move a file or directory from one location to another location, but it will never change the permissions of a file. For example, it will never change the okay, permissions of okay, it will never change the properties of a file. So even properties, what are the meaning of properties? Owner of the file, group of the file, size, date, time, all this will not change. So these are not going to be okay change. These are not going to be okay change. So even in Windows also the same functionality, and even in Unix also same okay activities. Now I have a file name called okay test. So what are the how do we get a properties of a file? Stat is the file name, okay, stat okay, file name. Stat is a command. With the help of stat we can able to get the statistics, okay, statistics. So if you take this okay stat command, so if you take the stat command, so are we able to, what are the access time, modify time, change time? There are okay. Now let's go back to one line earlier. So we do have a yesterday's content here, right? Yesterday's content okay, we are having here. So let's take okay this guy. It is also having a data. Okay, stat, okay, file name. So here when this file is created, 13 modified change, and okay, inode number, what is the inode number? And nothing is okay, these are the properties. Now I am going to okay, the syntax of mv is mv old file name, then new file name, and okay, directory also mv existing and okay new, just existing and okay new. So mv hyphen hyphen okay help. So these are the okay, multiple options okay, what we are having. So but we don't use all of this. Hyphen f means okay force, and okay no color, okay, these are the, but we don't use any of these options. So what we do is, so we are having a file called stat test.txt. Now I want to rename it just mv, okay, just mv test2. Okay, I'm going to okay, rename it as okay some the name, okay, then okay rama dot okay txt. I just rename it as a rama dot okay txt. Now run this command. After running this command, the file I renamed okay, from test.txt to the rama.txt. Now go ahead and okay, run this okay, stat command. Go ahead and run the okay, stat command. So this stat command, so let's put it on, okay, here. So okay, here the, yeah. So here only the file name is changed. The size the same, blocks are same, and inode number. Even inode number is also same. And okay, even accessed modified a change. They okay, they didn't change. What are the only change here is file name. Just the only change okay here is okay file name. So here it is a test.txt. So here it is a rama.txt. This is the only change. And similarly, if you try to change, if you try to okay, if you don't want to okay stay this file on here, and if you are trying to okay move it to some other location, just mv var temp. But if you are trying to move a directory to okay some other location, there you need a permissions, there you need a permission, write permissions on the directory. And if you want to rename a file, you want to okay, require write permissions on file. So the write permission is mandatory to perform these operations. Now, so if you check on okay here the same stat command, you don't okay you will get exception. Whereas now go to var temp and okay run okay stat.txt. So after moving to here also, okay there is no change. There is no okay change. The context, access, everything is okay same. Everything is okay same. So what is the simple? With help of mv command, we can able to rename a file or directory in the current location. And if you want to move the same file from current location to another location, that also we can able to achieve it. For example, if you go with an here, so let's go. If you want to rename a directory, so for example, this is a test, and you want to rename it as okay, test 123. You can also, sorry, since Unix is a case sensitive, we should always use lower cases. We should always use the lower cases. So test 123. So if you want to move the same mv test.123 to vartem, test.123 to vartem. This is how we can able to rename a file or directory in the current in the current location or to the different okay location. These are the functionalities of mv command. I hope it's clear for everyone. So inode number will not change. The same functionalities on Windows also. Now we do have a command called okay cp. We do have a command called okay cp. What cp command okay does is, what cp command okay does is, with the help of okay cp command, so with help of okay cp command, so with help of okay cp command, we can take, we can take the backup of okay file. We can take the backup of okay file. We can take the so backup of okay file. That is the one thing. And okay backup of file okay in current okay in current location, current location, backup of a file or directory, so our directory in current location. And we can also move same file or directory to okay other location okay with the same name, with okay same name. And one more thing is the mv command, the mv command creates mv command okay mv command. So the moment when you run that okay, mv command, it doesn't okay it doesn't require any storage because we are just renaming the file name. Whereas the cp command, so if the existing file is having 1 GB, the new file is also required okay 1 GB, which means that so with help of cp command, alternatively this is another way to create a new file with help of existing file, with help of existing file. So when do we use the cp command? So assume that you are having a file or a program, and you have decided to make some changes on the file or program. So then okay the best practice always is take a backup of okay directory or file, so that if something goes wrong, or okay some if something goes wrong on our new file, we can simply okay you can simply delete that file and we can rename this file to, so that you will be having a original content at any point of time. So that's why cp command we always use heavily okay to take the backup of okay file or okay directory, to take the so backup of okay file or okay directory, backup of file or okay directory. So is it clear? The okay now let me try to perform the operations, let me try to perform the operations. Now I have a file called okay cp rama.txt, and okay, I'm going to use it as so okay 1.txt. So now go ahead and okay, run these guys. So now what happens here? So the same file, okay, the same file, the new file created rama1.txt, and the timestamp and everything got changed. So okay, stat rama1.txt. So here the new inode number, okay, this is the old inode number, new inode number, and okay, the file name is already changed. So the access time, modified time, change time, it changed to the current timing, current timestamp. So 950, 950, and the everything got okay, changed, and it also created a fresh file as well. So that is the intent of CP command. So we are going now. Assume that you want to make some modifications on this file. Go ahead and make the changes. Then if you feel that okay, there are something went wrong, then remove this file and rename this file as a backup file into original file, so that you will be always okay safer. You will be always have a backup facilities to recover the original content. Now, so as part of cp command, there is an option called -p, very, very important option you need to remember. What -p does is, so now I'm going to take, for example, okay, rama underscore txt underscore okay backup 2025 okay 05 okay 16. I have taken a backup. So now what is the intent of -p? So now see that okay magic. There is nothing magic. So okay, here what happened okay here is, so now the Rama, okay, the backup file and the current file, the timestamp is not changed. The timestamp is okay not changed. Now go to stat. So Rama and okay this guy. So if you go with this one rama.txt and this guy, okay, the access time, modified time, change time, this is not changed. So which means that if you use -p, it preserves the properties of a file. It preserves okay, it preserves okay few properties like a date, okay, those properties it preserves it. So if you go with, if you want to take the backup of I mean your backup file also should be contains the same date and time, then we can use the -p option. You can use the -p option. That is the intent of -p. Whereas if you want to take the backup of a directory, so for example, now test underscore okay underscore, for example, if you go with okay backup, you will get an exception, because cp command without of any option works for only file. If you want to change the, if you want to take the backup of directory, we need to use the -r option, cp -r. So test and okay test, these are the two options what we are having it on, okay, what we are having it on okay cp command. So now go ahead and run. So the backup is okay taken. Whereas for example, if you want to okay, if you want to take the backup of a file with the same name, then we can move to some other location. We can move to some other okay location, home by, so okay home by ram by okay test. So okay, or okay, just okay, go on okay here, and okay again okay cp hyphen okay p okay cp hyphen pr. So okay test two okay, or okay test 1 2 3 backup to, so the same location, okay, to the same location. So now go to okay here, there will be having the same entries with same name. So that are, those are the options of okay cp command. So the options of okay cp command. Cp command is used to change the, so the main intent of the okay, cp command is used to okay, take a backup of file. We can, if you want to take a backup of file, that can be achieved okay by using this okay cp command. It's a simple and okay straightforward. So what are the differences of okay these guys? What are the differences of okay these guys? So mv command doesn't require a storage. It will just okay rename the file. It keeps the okay, and it keeps properties of a file as it is. Whereas cp command by default, so cp command okay freshly create a new file, and it also occupy the storage on file system, and it will also change the properties. It also change the properties. What are the properties? Timestamp, all those things will be okay changed. So what are the important options of okay cp command? Just execute cp hyphen hyphen okay help. So hyphen a, so not needed. Hyphen f force. And okay, for example, if you want to, okay, if you want to, okay, I mean, if you want to create a hard link, so I will tell you what is a hard link and all. So okay, then instead of creating a copy, we can also create a hard link. That I next topic is okay links only, and okay, the P C R. So okay, for example, if you want to keep okay, preserve the properties, to preserve what are the thing it will preserve? It will preserve the so mode, ownership, okay, even permissions, all those will be okay preserved. And okay, hyphen R means okay recursive, the same as okay hyphen R. And okay, if you want to create like a symbolic link, hyphen S. So okay, these are the major options of major options of okay major options on a CP command. So any doubts on okay CP command? Let me know. If you're having any doubts on CP command, let me know. So any doubts? Yeah, we can unmute yourself. It's simple only, nothing much. Okay, nothing much. I hope it's clear. Now we'll also discuss about. So we know. Okay, we started learning how to create a file, how to create a directory, how to rename a directory, how to take the backup of directories or same files, how to change the permissions of the file, ownership, okay, group. So how to take the backup also. There is another way to take the backup of file. There is another way to, there are, okay, now if you go with cp command, what cp command does? So now currently I'm on okay here. So rama.txt. Now let's take it as okay backup of this guy. So backup. So if I try to okay add some context on okay here, for example, assume that now I want to okay context. For example, I want to add okay some data onto this file. So double greater than okay rama.txt. So after running this command, now the content is completely changed. For example, if you go on okay, from this file to this file, so this is the original backup file. But whatever the data you are adding on okay here, it is not coming to here. It is not coming to here, which means that so that the time when you take a backup, that time whatever the data is having, that data only contains this guy. Whereas I have a requirement that I want to change, okay, I want to take a backup of file. I want to take a backup. I want to take a near real time okay backup. So real time backup. So I want to take the real time backup, which means that so if I try to add some text on text on my backup file, it will also okay, reflect to here or vice versa. If I make changes on okay here, it has to reflect okay vice versa. So assume that there are some important files. So okay, the some people are trying to insert the data. So okay, assume that okay, if you delete that okay, some due to some if mistakenly if you delete that file, so even we can't able to recover it. So in that case, what we will do? We always take the backup on the okay on a current directory or some other directories. So in this case, what will happen? So if you are making the changes on that file, so there is already a backup for us, right? There is already backup for us, so that again we can okay, recreate the file. So which means that whatever the data you entered on okay main file, it has to be reflect on okay backup or vice versa. So in this case, what we can do is Unix is having a concept called okay links. Unix is having a concept called okay links. So when okay there are two types of the links. One is okay hard link and okay soft link. Hard link and okay soft links. The hard link means so the links are a mechanism. The links are a mechanism to take the backup of okay to take the backup or to maintain a okay to maintain okay same version of a file okay same version of a files or directories into some okay different locations into some different okay locations. So in hard link, the syntax of hard link is ln, okay, source and okay, source, then okay, destination, source and okay, destination. Now let me try to run this command so that okay, we'll do the practicals so that okay, we'll be having So I'm going to okay, remove this file, just RMF. So now I'm having a so MV, so text to text, text. Now, so if you observe this one, okay, here permissions also it's a file. There are no okay links also. There are no okay links as well. Now what we are trying to do here is, so now I'm going to use ln-s rama.txt and I'm going to specify as okay, and I'm going to specify it as okay backup something okay I'm trying to okay specify now on the same location. Now ls-lrt. So sorry. So ls hyphen okay lrt. So ln source and destination. Now if you see this one, so earlier when you run this rama.txt, what is that okay here we are having only the number called 1. If you check on here, it contains a number called 2, which means that as I told, this is a file type permissions. If you are having a dot represents total 10 digits right here. So okay, instead of dot, you will be having a T if you enable a sticky bit. Now this is a one number of okay links to a number of hard links to your file. How many hard links to okay? How many links to okay? This guy is having okay 2. This guy is having the okay 2. Now so go ahead and execute the stat command. Stat rama.txt and okay these guys. If you run these two guys, so now file and okay the inode number. What is the inode number here? 3439998 3439998. So the remaining things access, modified, change, everything will be same. So everything will be same except this okay name. Except this okay name. If you compare anything, everything will be okay same. Everything will be okay same. So what we are trying to do here is, so now if you go with okay, if you go with okay here now, so okay, for example, okay, I'm just okay, removing the content. I'm just removing the okay content cat. So for example, okay, just greater than see, okay, if you want to remove the content of a file, just execute greater than file name so that the content will be gone. So if I remove the content on here, it remove the content from here also. For example, now I'm going to okay add, I'm going to okay add cat so greater than so rama.txt so hi hello 1 2 3 just control c ls hyphen lrt. Now the size of these guys are okay same 15 and 15. So cat and okay cat and cat. Now for example okay if I try to okay add, so for example okay if I try to add cat double greater than, so here so okay we are okay learning, okay we are learning about okay hard link and okay soft links. Just okay one control okay C. Now execute ls hyphen lrt. So both the size are 65. Now cat. So okay okay here and cat of this guy. So okay both will contain the same data, which means that if you make a change on okay one file, automatically the changes will reflect into another okay file. How it will reflect to another file? Because both files are pointing to one inode number. So as you know that inode is a standard, inode represents the physical entity, physical representation of a file or directory. So if you make a change on one place, automatically it will make changes on okay, other place, automatic change on okay, other place. We can also create the same hard link. So we're having okay, the same okay, I mean with help of existing file, we can also create a okay hard links. We can also create a hard link. So for example, if I'm going to okay use it as okay here. So for example, okay one, we can also create it now. So ls hyphen lrt. Now it will be having a okay 3. Now we are having a 3. In the 3 because so with help of okay this okay hard link, there are three names are associated. There are three names are associated. There are okay three names are okay associated. So ls hyphen I, what is the inode number of okay this guy? So what is the inode number of okay this guy ls hyphen I? So okay here. So okay, I mean okay this way. So with help of okay this we are okay. I mean so okay this is how we'll take the okay near real time of okay near real time. So whereas in Unix we're having different file system, right? So for example, if I want to take that same backup on other file system. If you want to take the same backup on on so on different file system. So for example, if I want to take it as under root. Now I want to take it as under root. So we'll get a exception. We'll get a so exception and even we can't able to create a. So for example, if you go with if you mention var temp, so var temp, so we can do that. So which means that so and one more thing you need to be remember here is so now it will be 4. If I remove this guy's source and still target is usable. So still target is usable. If you run this cat command, so earlier we are having 4, right? Now it is reduced to 3. We are having the same content. For example, if you are removing this file, so now if you are going to remove this file, so now you can able to see that 2 entries. Now we can able to see it as a 2 entries, which means that so if you delete a source file, target is still usable until unless if you remove. I mean, we can able to access the content of a file. Content as a file. At least one name exists. At least one name exists. We can able to access the data. We can able to access the data. So this is the functionality of soft link. So functionality of the hard link. So if you try to create a hard link for directory, for example, ln, so test one, so test underscore directory. So hard link is not allowed for the directory. So which means that so with help of hard link, what we can able to achieve it. So we can take so we can take or we can so we can mirror so we can mirror the file. We can mirror the file into we can mirror the file to a new name. So if you make changes on if you make changes on if you make a changes on source changes reflects on destination and vice versa. And what is another one? So we cannot we cannot create a hard link hard links for hard links for directories directory. And what is another difference? The another difference of this hard link is if you delete a source file, target is still usable because hard link hard link won't create a new file. Instead, instead a new name attached to the existing existing inode number. So which means so here the inode numbers are here we'll just make it as so inode numbers are inode numbers of so inode numbers of source and targets are same. Targets are same. So these are the this is what about so this is what about hard links. So in hard link, what we can achieve with hard link, so we can mirror the file to a new name. So inode numbers of source and targets are targets are same. So if you make changes on if you make changes on source file, so it reflects on destination, it reflects on target target or vice versa, target or vice versa. What is the meaning of this one? If you make a changes on target, it will affect on source as well. So we cannot create the hard links for directory. So the what is another advantages of this guy? So if you delete a source file or source file, target is still usable because the hard link because of the inode association, because of the inode association. So what is the syntax of this guy? Syntax is ln source source then, destination, okay, okay, source, then, destination, okay. This is about this is about so hard links. Any doubts on here? So any doubts on then the hard link? So hard link is nothing but, so if you want to take the backup of a file near real time backup of a file, then we go with hard link. So even on interview questions on competitive, I mean if you are writing any online exams and all, you will get a questions. What are the different types of links available in Unix? What are the differences between each of them? What are the differences between so each of them? So we do have a hard link. So hard link is for a file only. Now we'll execute the soft link. Soft link syntax is ln-s, okay, source and okay destination, source and okay destination. So why do we use this? Why do we use this? Soft link is there are different unique use cases. Different unique use cases. What we are having it on soft link. What we are having it on soft link. First, how do we create a soft link? We can create a soft link for a file or for a file or for a file or for a file or directory. So ln-s. So ln-s. So now run this ls-lrt. The number is not changed, but the beginning of the line contains L. The beginning of the line contains L. L represents a soft link, or somebody will call it as a symbolic link. Some people will also call it as a symbolic link. Symbolic link. Then if you execute stat command, if you execute the stat command of this guy and this guy, the inode numbers are different. The inode numbers are different. Okay, this guy inode number is 3440386, but this guy inode number is 19772, which means that the inode numbers are different. The inode numbers are the first inode numbers are inode inode numbers are different. Inode numbers are different. Okay, for both source and target. Source and target. So what will happen is if I remove a source file, so if I remove a source file, so okay, if I remove a source file, so for example, okay, if I remove a source file, for example, assume that I'm going to remove this, okay, rm minus f test3. So okay, rm minus f, okay, test3. So rm minus f test3. So if you remove a source file, the soft link file is unusable. So for example, if I try to use the cd this guy, so we can't able to access. You can't able to access it, which means that so if you remove a source, if you remove a source, if you remove a source, target is unusable. Whereas, for example, again, if you create a directory, for example, again, if you create a directory called okay test3, okay test3 again, so we can make okay use of okay this guy again we can make use of this one, which means that so in soft link, the inode numbers are okay different. So if you delete a source file, target is okay unusable. Whereas if I try to okay add okay new data, if I try to okay add okay new data, so if I try to okay add okay new data, so if I try to okay add okay new data to that okay existing okay, for example, this is a file, right? So if I try to add it on okay here, so go ahead and run this guy. So soft link and okay, rama.bk. So both the places, even if it is a soft link, if you make okay, if you make a changes on either source or destination, changes will reflect to that, changes will reflect. Whereas if I try to remove the source file, if I try to remove a source file, so if I try to okay, remove a source file, target is okay unusable. Now if I go ahead and run this cat command, we can't able to, so you will get that okay, will get so file okay, no such file or okay directory. So if you again create a touch of okay this guy, again this will be useful. Again this will be useful. Again this will be useful. So the same function we can able to achieve with a hard link. Then what are the main significant differences? In soft link, INO numbers are same. So if sorry different, if related source, target is unusable. So hard link creates a new file, whereas soft link will not create a new file. So, sorry, hard link doesn't create a new file. Soft link creates a new entity. So now, so that is for straightforward. The another advantages of okay soft link is the another advantage of soft link is, so what is the utilization of okay here? So for us, so okay, for example, okay, for us, assume that okay, df hyphen okay h, df hyphen okay h. So okay, here, so let's go to let's go to dev, or okay, yeah, let's go to dev. So okay, not here, I think I can't, we can't. So here df hyphen okay h, so df hyphen h. So the another advantages of okay soft link is it's mainly for the directories where we go with that. So here, what is the utilization of what is the total allocated okay size of what is the total allocated okay size of okay, this guy 920 MB, and okay, here the size of okay these guys are 184 okay MB for okay these guys. Now go to this location, go to this location. Now, so for example, so now okay, now you have a requirement that okay, run user dot forward slash zero. Okay, you want to run some okay, you are having a program. So in that program, the program is okay having, and it is generating the data. Whereas okay, try to understand okay this statement, whatever I'm trying to say. Now, so this is a different file system and this is a different file system. Now I want to I want to okay, now I want to create okay, for example, what is the size of this guy? 184 MB, 184 MB. So since that the size is 184 MB, for example, let's consider cp-pr. So okay, ram, okay, home by okay, ram by okay, star to okay, here I'm trying to so copy entire thing to okay, here. So now we are having some data. Now execute df hyphen h okay dot. So okay, used is okay this much, okay, size is this guy, and okay, used is okay this much, and available is okay this much. So for example, okay, let's okay, try to create okay one okay huge file. Try to create a so okay one okay huge file. So let's so create it as okay huge file. Hmm, I'm going to create a so okay vi for learning purpose only. So now df hyphen h dot. So okay, still it is okay having the used is 1.4 MB. So now what we do is, so we will try to create a so CP TCS to TCS okay one dot okay txt. So I'm trying to okay utilize the okay space of okay this guy ls hyphen lrt. Now cat, so cat greater than so TCS okay 2 dot okay txt, 3 df hyphen h dot. My God, still how much we need to try this guy. So the main okay, intent of this guy is now it is 9 percentage, right? So what we can do is, so quickly we can fill it up. So okay, cat. So at one point of time, so we will get okay some exception greater than TCS. Okay, I thought of generating the file in advance, but yeah, that's fine. So df hyphen h dot. So it is 35% of utilized, right? So quickly, so the with the help of next command, we can quickly finish it up. So 35 plus 35, 70, it will make it as 70. The next one, okay, will get as exception, 7. Now df hyphen, okay, h dot. What is the 69 percentage, right? So now, If I try to run a same file again, for example, same command okay, again, so now 8.txt, so okay, write error, no space left on device, which the same on Windows also, right? If you don't have a space, then okay, what kind of error message we will get? We will get that okay, okay, space is completely so occupied. Space is completely so occupied. So in this case, so assume that so okay, I mean okay here I have a okay less space assigned to me, but I want to generate the size, okay, more than that. Now, what is the allocated size of this guy? Df-h. What is the size of this guy? 100 per, okay, now, okay, the size of this guy is 184 MB. But I want to generate, okay, 2 GB, 3 GB files also, even though I don't have a space. So in this case, what we can do is, we can able to, so what we can do is, okay, we can create a soft link. We can create a soft link. How we can achieve it here is, okay, go to okay cd okay okay I mean okay cd forward slash okay vartem cd forward slash vartem. What is the location of this guy? It is on okay root. Now I'm going to create mkdir. So I'm going to create mkdir. So for example, let's consider our program is okay tcs underscore okay programs. Now I have created a directory. Now I have created a directory. So with the help of this directory, I am going to create ln-s. So okay, ln okay, I have created one okay, okay, I have created one softly okay, created one directory, right? So with this directory, I am going to specify what is the path of okay, this guy. So this is the path forward slash. So okay, tcs underscore okay, whatever the names, tcs underscore programs. Now go to, so now execute ls-lrt. It clearly says that. So now go to okay cd okay on okay this guy cd on okay here now ls-lrt. Now we can able to okay see that we can able to okay see that. So okay for example okay here so ln sorry rm minus cf. So ln-s, what is the source of okay, ours? So okay, where okay temp. So TCS programs just okay enter ls and the same way. Now we can able to earlier syntax was incorrect. We have to always specify this okay source full path. Now what we can do is now mv. So all these okay TCS, all these okay TCS okay star to okay okay to this guys okay to this guys now star. Okay, now star ls hyphen okay lrt mv tcs okay dot txt okay star 2. So now we have moved it. Now go ahead and run the df hyphen okay h. Now the utilization is 184 MB, but we are having a folder called TCS programs on okay here also TCS programs on here also. But so the thing is, so with the help of okay soft link, what we can do is we can make use of other file system uses into the current okay file system. Now go to this directory and okay now run this okay cat command. So if you want, we can create okay 8 also, or for example now okay 8 right. So okay 8 and okay now greater than okay 9. So in this case, what are we trying to achieve here? So it is a kind of a symbol. Okay, now if you go ahead and run that, okay, utilization will never change. Where the utilization will be changed, the utilization will be occupied on okay occupied on root. Earlier it was so now 7 percentage, right? Now it is okay 7 percentage. Now go ahead and run. So okay here okay 9 and okay greater than okay 10. So greater than okay 10. So what is going to okay okay here what we're trying to achieve here is we are going to utilize the file system of okay other okay we are trying to utilize the other file system okay into current file system. Now go ahead and run. So it is a 9 percentage, which means that we are okay. But so here also we are having a program. So if you are program, see even from here also we can able to see where are you currently. We are in this current location only. If you execute lsf and lrt, we can able to see the files. But the actual storage location of okay these files are from okay different file system. This is the one of the major advantages what we are going to achieve with what we are going to okay achieve with okay this guy. What we are going to achieve with okay this guy. What we are going to achieve with okay this guy. So okay, soft link is for a okay, soft link is a kind of okay symbolic okay link. Soft link is a okay symbolic link. It can be used for directories or okay files. So what are the main advantages of soft link? We can make use of okay other file okay other file system space into current file system space into current file system if you don't have a enough space. If you don't have a enough okay space. So for example, if you remove this directory or if you rename this directory on okay under var term, you can't able to make use of this guy. You can't able to so okay make okay use of it. You can't able to so okay make okay use of it. That is the so main thing you need to be okay remember. That is the major okay things. So I hope it's clear for so everyone. So soft links are so very important. And the one more soft link okay one more place what where we use the soft link is so we have a okay here. So this is the okay physical file system. We are having a physical file system. DFIFNH means this is the okay. These are the file system are available on your system on okay on your okay server. Whereas assume that so whereas okay assume that so you are having so okay you are having okay you are having a two servers. Assume that you are having a two servers, server 1 and like a server 2 and like a server 3. Now so the server 1, server 2, server 3 you are having okay one more server. So for example okay here okay I have so we are having a servers but okay we are having a laptops on okay we are having a so laptops we are having a okay laptops. Now so assume that so for example, with the help of some program, there is a facility. What we can do is so okay here there is a okay there is a hard disk. The capacity of hard disk is of 5 terabytes. The capacity of hard disk is 5 terabytes. Now, if you want to make use of this okay 5 TB hard disk, okay on from okay here from here what we there is a so we can able to achieve it. Okay, we can able to achieve it. So the only thing is all of them are in a same network. And so this server and all that okay all the okay this server and okay this okay laptops and all should be on same network. Should be on okay same network. That is the first prerequisites. And okay there are some programs. So with help of that program we can able to enable this file system okay the local file system as okay network file system. We can enable this okay file system as network okay file system. So one okay the same file system for example what we can do is since we don't have a space on here right so we can if you we can also create a files and we can store it on okay we can store it on okay this server from our server itself. So those kind of okay file system we call it as a network file system. So even for network file system also we use the soft link. Soft link is okay one of the okay key concepts on okay NFS also. So okay it is a so even while creating the NFS okay NFS during that time also okay we use this okay we use this okay soft link okay soft link mechanism. So NFS is a separate setup. So NFS is separate setup. How do we enable the NFS? So okay, how do okay, okay how to enable? So how to enable okay NFS? There is a okay there is a systematic approach. There is a systematic approach in UNIX. So okay there are lots of okay things. For as I told you that. So these are the okay these are the clients. This is my system. So MNT share is the NFS server. So I have one directory called apps. I want to make use on okay here. How do we do that? The same one okay here. So this is okay here is the okay here is the okay syntaxes. Here is the syntaxes. So first we have to install the NFS. How to install the NFS? By using the M command. After that we have to create a shared location mkdir NFS. After that okay we need to set ownership and okay, we need to export and okay after that we need to enable the firewall. We need to configure the network. So as I told network right network and set up your client. So you need to log into the client system and we have to run okay these commands. We have to run so these commands. These are the commands what we are having, but it's not our work. This has to be done by system admins, not by us. So not by okay us. So even on that scenario also so okay we'll try to okay use this okay soft link. So soft link is one of the very important. So if you want to make use of okay other file system into the current file system we can use this okay NFS sorry we can use this okay soft link. So, okay, these are the major differences between the hard link and okay, soft links. One is source and destination. I know numbers are different for both okay, source and target. So if you remove okay, if you remove source file, source target okay, source, then target is okay, target is unusable. And okay, another advantages is we can make okay use of okay other file system okay, use okay, other file system okay, space into current okay, file system. So okay, we can create a soft link. So okay, we can create a soft link okay for file or okay directory for file or okay directory. So within file system okay, and other file systems as well. Other file systems as well. This is the So okay, these are the main things okay, what we are okay, having. For example, if you go with okay, same hard link, so for example, assume that okay, I have this one, right? So now go to okay here, don't have one. So we are having the files, right? Now, if you want to create a hard link for this guy into some other okay, file system, for example, if you want to create it on so okay, home by okay RAM. So root can be created, but okay, others cannot able to be. So within the files, okay, root will be having a privileges. So okay, these are the major differences between soft link and okay, hard links. And I request everybody to okay, install okay, Linux operating system. If you're not installing the Linux operating system, there is no okay usage. There is no okay usage of okay. I mean, we can't able to do the so practice.